Hey guys, what's up? Welcome back to the channel. I'm Anirban and I'm here to make you a better programmer. So let's get started with today's video. In the last project, we have created one mailing application, decentralized Web3 mailing application. In this video, we'll be creating one voting system, a decentralized voting system where any user can go to that smart contracts and vote for any particular candidate. No one will be able to stop that person. There will not be any rigging, vote rigging or anything that is possible because it's all secured by blockchain and cryptography. So let's get started. What we need here, first what we'll use, in the last video we have used remix to create our smart contracts, but in this video we'll be using something called Hardhat, which is a much better in my preference is much better way to manage your smart contract code. So what we will do, we'll go to Google and search for Hardhat dot. Let's directly go to the website hardhat.org. So this is Ethereum development environment for professionals, and let's get started. So it asks you to install it's a node package, so you will have to have node modules installed or node packages installed. So if you don't have node installed, just go to Google and search for node js.org and download any of the node whichever version you choose. For me it is I'm using version 18. You can use the same or whatever is the latest for you at that moment. Once you have node installed, you can directly open up a terminal. Let me show up a terminal, and here what I will first, let's go to our project folder, cd repos YouTube projects, and here I will create one new folder. We'll call it Web3 voting, and once this folder is created, let's go to this folder. Now what we can do, open up a Visual Studio Code in this folder. Okay, we have our okay, before that, let's not do that here. What we will do, we have to create two folders. One is for the smart contracts and one is for the UI of our dApp. So folder where we have the smart contract will be a different project, and folder where we have our UI will be a different React project, UI project. So we'll first create the contract folder, dApp. Let's create a we can just directly call it dApp. Then open the Visual Studio Code here. Okay, so this opens the dApp folder, and there's lots of things that is not required. Okay, now what we want here is let's open up a terminal. This will open up a terminal inside our Visual Studio Code. I hope this is good enough zoom. Okay, so now we can follow this particular 1 minute. So let me just put it here and put this thing in this section. Yes, okay, it looks good. Yeah, now what we need to install Hardhat. So before we do install Hardhat, we have to initialize our node project here. So to do that, we'll do npm init. This will initialize the project with the project called Web3 voting, and package name, oh, it has to be all small case, Web3 voting. Looks good, and we can directly just keep on click enter. So this will Okay, so this will create a file here, package.json. What I will do now, will install this Hardhat library. Okay, so we have finished the installation. Now let's use the npx Hardhat to initialize our Hardhat repo. This will ask you where do you want to, what kind of project that you want to create. You want to create JavaScript project or TypeScript project, or is just an empty project? I'll use TypeScript project. That's so the root of the project is this. It's fine. Do you want to use git ignore? Yes. Do you want to use sample project dependencies like yes. No, why not? So now you can see all the boilerplate codes and all the configuration files are there. Now we have a folder called contract. Here we will be using our writing our own contract. So let's create a contract called Web3 voting, or let's call it dab voting. Let's keep it that way. Dot sol. Our Hardhat initialization is still working on, but we can still keep on writing the code here. What I will do, there is a sample code written in the as a lock.sol. I'll just copy this part, and we'll don't need anything else. This is the boilerplate that every code contract should have. So we'll just rename the contract name to Web3 voting. Now we have our basic project setup. What we need to do is we need to write all our voting logic here. So to write a voting logic, we need a sets of variables which will store the candidate names and their IDs, and sets of variables or mapping which will store the count of their vote. And also there should be a mapping or there should be a storage or any data information where we should track whoever has already voted, so that there should not be any double counting. Okay, so how will we start with this is, we'll first create one struct which is basically a custom data set, custom data type for our library or for our contract. We'll call it candidate, and here we will store the ID of the candidate. So it will be unsigned integer ID. We'll need a string to show the name of the candidate, and we'll also need the vote count of that person, vote count. Okay, so we have all these three. This is what we need to store information of the candidate. What else we need is the information where to store whoever has already voted. So we'll need a mapping for that, and the mapping will be okay, address should point to a boolean, like if that person has voted or not. So if it is boolean, if it is true, then that person has already voted, and it should be a public value, voters. Now we have a voters section. Okay, so these are the voters who have voted, and we'll also need to store a count for candidate, how many candidates has registered. Candidate count. The moment we add one candidate, this will go up. It will start with 0, and we'll need a mapping for us to identify any candidate based on their ID. So it will be ID, which is unsigned integer, and the candidate. It will point to a candidate. So this will also be public. Candidates. I think it's good, maybe. Okay, so one other thing, it's a good practice to throw events for whenever there is something happened in your contract, so that other contracts or other UIs or any other external stuff can subscribe to those events and do others, plug into those events, and they can do other stuff if they want. But as long as we have those events firing, in future any other tools or any other smart contracts or a UI can subscribe to those events and do enhance the user experience. So for that we can throw an event. It's not a necessary thing. Vote event, and we will throw the ID of the candidate, and this will be indexed so that we can search it. Indexed, and we'll have the candidate ID. The moment anyone votes for one candidate, we'll throw this, will call this event, and this will this can trigger lots of other contracts if other contracts is subscribed to it. Okay, so to make things simple, what I will do, I will just hard code the candidates for now, so that we don't have to worry about permissions that admin can, whoever can register a candidate. So at the time of deployment, we will have the number of who will have the information of the candidates ready. So after the deployment, there will not be any changes, or there will not be any addition of new candidates. So we'll call a add candidate. We'll create this function in a while, and we'll just call the candidate name. Let's start with 2 candidates, and just for fun, let's make it Obama, and let's make it Modi, because I'm an Indian. Why not? So let's create these functions. Function and add candidate will need the string, and this will be memory and name, and this will be a private function, so no other other than the contract itself, no one from external, no one externally should be able to call this function. So that means after I deploy, I will not be able to call, or no other public person will be able to call this function. And so what we will do here is we'll increase the candidate count plus, and we'll also add this candidate to the candidate list. Candidates, and we'll call the candidate count equal to candidate, and ID of the candidate will be, first is the ID, then the name, the vote count. ID will be the candidate count, and the name is the current, whatever name is supplied in the argument, and vote count is 0. So we have our first function ready to add a candidate. Now we need the most important function, which is the voting function. Let's implement that. Vote. So in the vote, we'll need the candidate ID, and that's all. Unsigned integer, and we'll call it candidate ID, and this will be a public function. Anyone should be able to call this. Now we should have some guardrails, so that if the person has already voted, should not be able to vote. So we'll have a require, and the condition will be voters. The voters, we have this voters variable, which is tracking down whoever has already voted. msg.sender, sorry, this is a mapping, so this should look like this. And if it is not, if it is already this should be false. so this person should not have voted. So I'll just make a invert of that, so it should be not voted. And if that person has already voted, so I'll call it you have already voted, 3 exclamation mark. Voters. Okay, so this will be voters. This is one condition. We need another condition is if the ID of the candidate is invalid, so that means if the candidate ID is negative, or the candidate is more than whatever the valid ID, so we'll just make it an invalid candidate ID. So we'll just need another requirement. Candidate ID that has been passed for voting should be greater than 0. We don't have any negative candidate ID, and candidate ID should be less than or equal to candidate count. So if there are 2 persons, we should not be able to vote for ID 3, so there is no third candidate. This is some basic requirement. Let's add some error message if that is not true. Invalid candidate ID, we'll call it invalid date ID, then again some exclamation mark. Okay, so now that we have our basic criteria ready and guardrails are there, now we'll just do our main operation for voting. What we'll do, we'll first make the voters that he has already voted, so that there should not be any double counting, equals true. Then we'll have candidates and the underscore candidate ID dot vote count, which should be this vote count plus plus. And now we should emit, this is not again necessary stuff, but we should emit one event, emit vote event. And okay, so it has already filled the. Now we have our vote function ready. Basically we have our contract ready. What we need to do is now deploy this contract. Okay, so we have our contract ready, and what we will do next, we will be deploying this contract so that we can interact with this contract from a UI and make some operations or do some voting on that.